Before we talk about typhoons entering the country, there's one question we need to settle first. How do we even know when a storm is officially ours to monitor? We start with the boundary, the Philippine Area of Responsibility or PAR. It isn't a political border nor a claim of ownership. It's simply a watch zone. It's the area where the Philippine government, through DOST Pag-asa, must monitor storms, issue warnings, and guide national preparations. If a storm enters this box, we begin tracking it. So how do we draw this box? We define it with a series of specific coordinates. A coordinate is an address where one latitude line and one longitude line cross. So with 6 of these addresses, we can draw the PAR. Let's plot them 1 point at a time. First coordinate 25 degrees north, 120 degrees east. We find our horizontal line 25 degrees north. Next, we find our vertical line 120 degrees east. Where they meet, that's our first point. Second point, same latitude, but we move to 135 degrees east. There's point 2. Third point, we now slide south to 5 degrees down the same longitude line. Fourth point, 5 degrees north, 115 degrees east. Now we head west along the same southern latitude. Fifth point, 15 degrees north, 115 degrees east. We move north but stay on this western longitude. And final point, 21 degrees north, 120 degrees east. Then we connect back to our starting area. And there it is, the box is drawn, the Philippine Area of Responsibility. Let's track a typhoon that entered PAR and left a mark in the Visayas. Internationally, the storm was named Kalmegi. Inside the PAR, it received its local name, Tino. Let's trace its path using data from Zoom Earth, checking every 12 hours. We first observed the system forming on November 1, 2 p.m. as a tropical depression just outside the Philippine Area of Responsibility. Our first data point inside the PAR is from November 2, 11 a.m. at 11.1 degrees north, 134.2 degrees east. On our map, this yellow dot marks a severe tropical storm. 12 hours later, it was at 11.2 degrees north, 132.5 degrees east. Is still the same category and moving westward. On November 3, 11 a.m., we see a major change. At 10.4 degrees north, 128.3 degrees east, Tino reached typhoon category. 12 hours later, it was at 10.9 degrees north, 120.3 degrees east. This point shows its landfall as it began crossing the Visayas. By November 4, 11 a.m., the storm was at 10.4 degrees north, 122.5 degrees east. Is still a typhoon but now exiting the Visayas. 12 hours later, it moved to 10.7 degrees north, 120.3 degrees east, about to make landfall in Palawan. By November 5, 11 a.m., it was at 11.8 degrees north, 118.1 degrees east, now over the West Philippine Sea. Later that night at 11 p.m., it reached 12.9 degrees north, 115.2 degrees east, nearing the edge of the PAR. And finally, on November 6, 11 a.m., at 13.2 degrees north, 111.3 degrees east, Kalmegi intensified into a super typhoon. By then, it had already exited the PAR and was heading towards Vietnam. Now that we've traced Tino's path, let's look at what's happening inside the typhoon as it moved. Let's follow the wind speeds. While Tino was still over the warm Pacific, its winds rose from 90 to 105 to 140 kilometers an hour, a clear sign of intensification. This brings us to our first key idea. Rule 1, warm water provides fuel. Warm oceans evaporate fast, adding heat and moisture, the energy that powers a typhoon. And over open water, low friction lets the storm spin faster. As long as the system stays over warm seas, it keeps intensifying. When Tino made landfall, its winds were about 155 kilometers an hour, but dropped to around 130 kilometers an hour as it crossed the islands. Here's the second idea. Landforms weaken a typhoon. Land creates friction and cuts off the storm from its fuel source, warm ocean water. Without that energy, the system loses strength. After crossing the islands, Tino held at around 130 kilometers an hour over the Sulu Sea, then re-entered warm open water. Over the West Philippine Sea, it strengthened again, 145 to 175 kilometers an hour, intensifying as it exited the bar. The warm, uninterrupted waters of the South China Sea helped it grow into a super typhoon. Now let's look at another storm that entered the bar days later, Wuan, locally named Wuan. Wuan entered the bar already a typhoon and quickly intensified, 125 to 155 to 185 a super typhoon, then further intensifies to 205 kilometers an hour. All this happened over the Pacific with steady access to warm water. So far, it behaves like Kalmegi until it nears Luzon. As Wuan approached northern Luzon, it encountered increased friction from the landmass, including the terrain near the Sierra Madre. This interaction disrupted the storm circulation, causing its winds to drop from 205 to 180 kilometers an hour, a pattern similar to Tino's weakening over land. But after that, Wuan behaved differently. Once it moved away from Luzon and returned to open water, we might expect it to intensify again, but instead, it weakened, 145 to 125, 110 to 95 to 85, down to 65 kilometers an hour. This happened even over the ocean. Why? Two reasons. First is slow movement. Wuan traveled only short distances every 12 hours. Slow-moving storms stir up the ocean, bringing colder water upward, a process called upwelling. And colder water means less energy. And second, the northern part of the bar near Taiwan and the Bashi Channel has cooler seas than the waters near the equator. Less heat means weaker storms. So these two storms followed the same rules, but they encountered different environments. This is why tracking matters. It doesn't just show the path, it helps us understand why a storm changes and what might happen next. We've tracked the storm's path, now let's move to the second part, how the country prepares, responds, and rebuilds. This system follows 3 stages. Stage 1, early warning and monitoring. Before the storm arrives, Pag-asa monitors weather systems and issues warnings and advisories. These early alerts give families time to prepare and allow LGUs to ready evacuation centers. At the same time, NDRRMC coordinates the National Response Plan while the LGUs and uniformed personnel like BFP, PNP, AFP, and PCG assist in safe evacuations and guide communities to secure areas. Stage 2, response and relief. When the typhoon hits, the focus is on protection and survival. DSWD provides emergency food and essential relief goods, while LGUs and uniformed personnel carry out rescue operations through floods, winds, and debris. Stage 3, recovery and rehabilitation. After the storm passes, rebuilding begins. The LGU and other authorities clear debris, open blocked roads, and restore access routes so communities can move again. DPWH repairs damaged infrastructure and restores flood control systems. The DOH protects public health and keeps medical services running. From warning to response to recovery, each stage forms a chain to protect communities. After every storm, the goal is to rebuild stronger and more prepared. Stay informed, stay prepared. And that concludes our Typhoon series.